Okay, we're talking about improper integrals. Two things that can make an integral improper. First, the obvious one, the one that's easy to see, is one of your bounds is infinite. Okay, one of your bounds is infinite. That we're finding the area from 1 to infinity of a function. And what we're actually finding then is the limit. Does the area approach a number? We're not going to get the actual area, we're going to get the limit. Okay? So similar to evaluating limits, we're going to use limits in this integral. The other kind is a little harder sometimes to see, but you look, 1 over x squared, we know what the shape of that is. There's a discontinuity at 0. So we're trying to find the area, and yet there's a discontinuity in the middle. It doesn't have to be at the middle, it could be at an endpoint. But the two types of improper integrals are an infinite bound or a discontinuity. In both cases, we're going to use some limit notation here. We're going to start by rewriting. Okay. So I'm going to rewrite this as a limit, and usually books pick the letter b. I'll stay with that, as b approaches infinity. Oh, okay. Sorry about my bad arrow here. Let's try that one more time. That's better. We're going to do from 1 to b of, instead of 1 over x squared, I'm going to write x to the negative second dx. Okay. And essentially we just do our integral like we normally would. You know, what's the antiderivative of x to the negative second? Well, we raise the power and divide, so it becomes negative x to the negative first. We're evaluating at b and 1. Okay, I'm going to put this in brackets because we're still, at the end, going to do the limit as b approaches infinity. Okay. Well, you know, negative x to the negative first, if I could just kind of cross that out and just remind you, that's negative 1 over x. Okay, so when I plug in b, I get negative 1 over b minus negative, now I plug in 1, I get 1 over 1. Okay, and I'm still taking the limit as b approaches infinity. Well, nothing I've done so far has been any different. I found the antiderivative, I plugged in the bounds, it's all just regular fundamental theorem part 2. The only difference is, right here at the end, I say, well, as b gets larger and larger, what happens to this fraction? It approaches 0. Okay, that's what it approaches. Well, 0 minus negative 1 is 1. So that is the limit of our area. So what that means is that, you know, if you found the area from 1 to 1,000 or 1 to 10,000 or 1 to 1,000,000, it's going to get closer and closer to 1, but never reach 1. Okay? The area will never reach 1. That's its limit. So we haven't found the area from 1 to infinity. We found the limit of what the area will be. Now in this next example where we have a discontinuity at 0, we actually have to break this into two parts. So we say, you know, we're going to do the limit as b approaches 0, and we could even say, you know, as b approaches 0 from the negative side or positive side to be a little bit, you know, more exact. B of x to the negative second dx, and then we would add that to the other side of the area, limit as b approaches 0 from the positive side. Okay. And of course we have the same antiderivative because it's the same thing. So it's going to be, you know, negative 1 over x evaluated at b and negative 1. Negative 1 over x evaluated at 1 and b. I accidentally wrote a 0 there. Okay. So when you do that, and again, we're still taking the limit as b approaches 0. Okay. For this one, the limit as b approaches 0 from the positive side. For this one. But what you're going to see, I hope you see this, because you really end up with the same thing. You end up with negative 1 over b minus negative 1. is then when you plug in 0, you can't do 1 over 0. It's undefined. And because they're undefined, we say that the limit doesn't exist, and therefore the area doesn't exist. We call this divergent. Okay? And if we can get an area, we say it's convergent because it's converging to 1. But in this case, we can't get an answer. We get undefined pieces, so we say that it's divergent. Okay? This example, the notation would be that we're doing the limit as b approaches infinity, 1 to b, 1 over x dx. Well, the antiderivative of 1 over x is natural log of x, evaluated at b and 1, doing the limit as b approaches infinity. So the natural log of b minus the natural log of 1, when we plug those things in. Unfortunately, the natural log of infinity is infinity. So we get infinity minus 0 because the natural log of 1 is 0, which is infinity. So this is divergent. We couldn't get an actual answer. Okay, so I want you to notice that 1 over x, we couldn't get an answer, but 1 over x squared we could. Okay, and that will be important when we get to series, the difference between those two. Okay, it really is just setting up the integral. The notation's important, but it really doesn't affect us much. We do the antiderivative, we plug in the bounds, and we see what we get.